I'll kick things off, get things rolling here. And so I'm going to try to maintain a scale of a residential landscape, talk about, those issues that we're confronting there. So there may be some terms or stuff that I don't, continue to talk about just because they're primarily just, overarching type issues. But if you do have any questions regarding anything that I don't, elaborate enough on for you, let me know at the end and we'll catch up on those. Or you can give a shout in the chat. I'll try to keep eye. I think Jennifer's going to help me keep eye on the chat there. So basically today, just kind of keep it simple. Just kind of cover the three objectives I have here today, and that's define salt salinity and associated issues. Kind of review those. Look at what's out there as far as guidance, and I got a number of EDIS pubs that I'm going to post in the chat later on today or at the end so that you can download those because I will reference those a lot. Again, just given about 45 minutes, I can't really get too involved with each one of them, but you can definitely build your library on this through those links. So, and last, offer suggestions, solutions as far as management and mitigation soil of saline soils, and kind of I guess just kind of what the end point here is. In Florida, we're very fortunate. As long as we don't have a hurricane that blows in a lot of debris, sediment, and traps a lot of salinity within our soils. If you have a Florida-friendly yard, particularly, you have a pretty tough salt-tolerant palate to begin with. Always special cases with annuals, but but there's always a obsession, and also things are always occurring within our communities that may offset that balance. So let's move forward with some terms regarding sources and what do we exactly mean when we talk about salt. When I was a kid, when you heard salt was just table salt. Didn't really think any more about it, and you got in school. It's NaCl. That's sodium chloride. But there's actually there's a whole host of other compounds that we consider salts. But let's go back to our chemistry days just real quick. A salt is a chemical compound consisting of an ionic assembly of positively charged cations and negatively charged anions, which results in a compound with no net electrical charge. So as you can see here, sodium and chloride, share that significant bond, so to speak. And once they are together, they create what we call the compound salt. And just to kind of give you an idea of what the other ones would be, on the left, you'll see we have the common salt-forming cations, and on the right would be the anions. And so I don't know if you remember way back, I know for me, it was way back when I was learning valences and covalences in high school and college. But basically, you see the charges like ammonium NH4, and you got the plus. That's a valence charge of 1 positive. And if we were to mix it or connect it with, say, nitrate, NO3, negative charge, that's going to make a salt. The same thing, again, if you were to pull out sodium and chloride, those unlike charges are going to attract. They both have the same need. One needs a positive, one needs a negative. They connect, and then they become a compound. So that's basically how these salts form. So, you can just start kind of imagining just by looking down the list here, things are probably going to start popping out with you as far as either nutrient values or other compounds that are also called salts. And these sources, basically, we have three major, venues or pathways to where we interact with salts. And the first one would be the natural salts. And those are just coming off the parent material, the natural geology of our state, or, take it back a couple of geographical geology as far as time-wise. Take it back a little bit. But again, it could be just the weathering, the corrosiveness of rainfall, what breaks these salts apart. and we'll get it naturally. And so we do have a natural source, and we have applied salts. And those applied salts going back again to those compounds like ammonium nitrate and or ammonium sulfate or ammonium. But you got potassium too, as well as chloride. All these are applied, and so we do get what we call, additions or applied salts within our landscape. So we need to be mindful of that as well. And third is the salts from our urban water sources, and those could be, salts entering from our water supply through reclaimed water if we're using that on our landscapes. Could be through maybe a saline well, slightly saline, or it could be wet, dry atmospheric deposition could bring in some salts. And so, and also water softeners, I put that in there too. Depending on your gray water systems, you may be, applying gray water legally, so to speak, now. And so those technologies require some oversight too, with, knowing what you're putting onto your landscape as far as detergents and water softeners. So, there's three major sources that we'll consider here today. So we do have characteristics, and the two characteristics I want to talk about are the soluble and insolubles. So the solubles are kind of like what I would call, again, going back to when I was a kid, Kool-Aid. You put it in water, turns a color, it mixes up, you drink it. That's basically what we're talking about with solubility. And these salts are extremely, they dissolve in water. They're very mobile at that point. And just some, again, going back to examples, sodium, potassium, calcium chlorides, nitrates, those are all soluble, and they can move within our water profiles. They're also readily taken up by plant roots. Plants do need salts in measured amounts, and also they could have some adverse reactions too. But the point is that typically when they land upon our soils, if solubles come in through, say, reclaimed water, it's applied to our soil, and then we get rainfall, which we generally get seasonally. It's going to move that layer or those salts that maybe have accumulated, being that they're soluble, they're going to move downward pretty readily. So that's one way we can think about soluble salts. And also, typically they will create a charge as far as conductivity within water, soil and water, and we refer to that as EC, electrical conductivity, which we'll talk more about. So they're insoluble. So as the opposite of soluble, they do not dissolve in water and remain in place in the soil. And examples would be calcium carbonate, gypsum, which is calcium sulfate. Those actually provide some tilth, soil tilth, some building some structure to our soil. So that's a good thing. They're not as readily absorbed by plants unless directly toxic. And again, they're not mobile, so they don't really leach from our soils unless they're carried off through erosion activity and stuff like that with runoff, stormwater runoff. And they have a characteristic. They do increase typically soil alkalinity. Gypsum not so much on pH, but over time they could again, be a buildup, and we have to be aware of that. There's a measurement called SAR or SAR, or sodium absorption ratio, and we look at the interaction of these insolubles as far as we look at the interactions of calcium, magnesium, and sodium, and there's a ratio. And once we get above a ratio that's not appropriate for that area, we could see some issues. And I do want to direct you toward I have a document that talks a little bit more about sodium absorption ratios. So that's something we can follow up on. So within the urban landscape, it's more or less, well, how do we get salts into our landscape? And it's through a couple of things, and one would be our water supply. It could be our cultural practices, going back to fertilization and some other cultural practices, or it could be saltwater intrusion. And saltwater intrusion generally been, directed toward groundwater because of our well systems or an influence that we have on our coast. Typically, we'll bring in some brackish or saltwater with the drawing of fresh water along coastlines, and sometimes our wells do turn over, so to speak, and go total salt. That's something else I'll just talk about later. But salt intrusion could be flooding, inundation, and other points of influence that it could have on our landscapes. We'll talk about that a little bit. When we talk about water supply, think potable water systems, your county, your municipal, and also your home well. If you have a residential well on your property, I mean it's not uncommon to find salinity in all three of these. Will it be harmful? Probably not. The one that draws a lot of concern is your well, and so we do have recommendations upon you should monitor. Sometimes the canary in the cage is when a plant starts to either defoliate or burn marginally on the leaves, something like that in that manner. You might want to start to question that well quality water. And then alternative irrigation, again, if you bring in the purple pipe, so to speak, the reclaimed water, that's one way you'll know it. You have the purple pipe and purple devices and a separate meter. Definitely, if it's below what we call tertiary, that third point of treatment, where it's not going through an RO, what we call reverse osmosis filtration, it's not going to remove enough salinity. And sometimes within areas, we will see salinity values increase with reclaimed water if it's not under a third treatment process or tertiary process. Brackish water, it could be that you live in a community that pulls directly off the canal. And, in older communities, that's something that you may see. And it could be surface waters that may be mixing with brackish water, depending on the water table that it may have. And also, again, your own site well water, depending on that. If you have those as separate from potable, something, again, you might want to consider if this is superficial type or if it's near brackish water systems. Cultural practices. Fertilization. We call this the ring of death. And, consideration of plant root systems underneath there and at high concentration, it doesn't matter about the nitrogen, it's the salt potential. And so typically, we using fertilizers that are high in salt will, if improperly applied, will affect plant root systems and eventually affect plant health. So the importation of fertilizer will bring in salts in the area, and if improperly applied, again, you're going to have some plant health issues. Irrigation timings. Your timing you may be overwatering. If you're using a reclaimed water system that does have a higher values of salinity, well, then that's definitely going to bring more application into that area. And depending on your soil type and depending on the season, it could be during the dry season. It may hold those salts closer to the surface area, within probably 4 inches, maybe within that area. If you're improperly watering, if you're not getting enough water sometimes to flush those systems downward is an issue too. So think about that too. Make sure you're always, following your irrigation system timings and also audits and resets seasonally. Plant selection, of course, that's your cultural practice as well, and that's usually your saving grace. We do have the FFL plant app that you can go in and look for salt tolerance if you need to. Stormwater runoff. We do have areas where the runoff could come off of impervious surfaces, bringing that wet, dry atmospheric deposition, exhaust deposition too, if it's a local surface street nearby, and you're getting washed back onto your lawn. And septic systems, especially during inundation, when we do have saltwater intrusion or flooding that occurs, those septic system plumes, they're supposed to be going downward. They could rise up and reintroduce these salts that have been collecting in your systems. If it's been a number of years, then you probably should expect a higher salt value, because there's just nothing in there filtrating out the salinity of that wastewater. So considerations, especially during flooding, storm events, if and it goes on for like 3 or 4 days, you might suspect that. Again, I go back to if we get our seasonal rainfalls like we should and our sandy soils are working within their capacities, it's going to do a lot of natural flushing. So, it just takes monitoring at that point. So, we again, just like I said, these human sources, anthropogenic sources can bring or import salts within our landscape as well. So I mentioned saltwater intrusion. Now I want to kind of explain a little bit more regarding a sea level rise and the influence it also has on our groundwater. And as you can see here, this is just a cutout of the coastline, and we do have brackish water systems typically underneath, and also freshwater above. And when we start to pull, we get this coning effect, and you can see on the right, I don't have my pointer on, I guess. You'll see the coning effect at these two wellheads. And so what that's doing, that's a pressure gradient, and it's literally sucking in the lateral movement of more highly saline water. It could be pure water, it could be brackish water, a mix. However, it's going to bring in some more salts than what we want. And also with sea level rise. So when our oceans heat up, they expand, and we're getting that additional push, not only from volume from glaciers adding to it, we're getting that push from temperature, pushing that water, expanding that water. And so some of the expectations would be that as that sea level rises, we're going to get not only that pressure, but the influence also from wells and overpumping. So we typically see this on the coastal side, and I call these straws, but within developments that allow residential wells for irrigation, we're going to have a lot more straws in there pulling at the same time, so to speak. So it's going to fluctuate our water tables. It's going to introduce salts. And a lot of times, once these systems kind of break the dam, so to speak, it's harder to push out this brackish water that's mixed back out, just because of all the factors that are going on within that area. So considerations for overpumping could lead to pulling in more and more saline type waters. Now, this is something that's occurring typically now during the fall. We have what we call king tides, and just want to recognize Larry here. You can go on YouTube. This is actually a walk. He walked. It's about ankle high, a little bit over his ankle. But this is at Delray, and he just walks out. He said, "This is something that's occurring now with king tides. Is this water, salt water, that is coming up?" And as you can see on the right, we do have some inundation. You can see the little white picket fence there, and near the back of that car, you can see that turf is actually underwater now. Also, with a lot of the plants that are on the left, as the screening hedge there, and also on the right within those lawns, particularly if it's hibiscus, it's not going to really go over well. That's just a sensitive plant. And it could just be from foliage. If we get the ocean spray as well, we'll get damage. But the point here is that these areas here may need some help in recuperation if they're not tolerant. So again, it goes back to the right plant, right place. It may be renovation time for a lot of these areas. I noticed at Palm Beach just a couple of weeks ago, Palm Beach downtown had inundation. And what you got to think about there too, and I know I'm not the engineering structural person to be talking, but I do know the influence on salinity and masonry, the influence salinity on other surfaces. It could degrade it, erode it, and then you'll have structural issues too as well. And it could be hardscapes within your landscape. Another thing to think about too, and this is a study that's going on. Actually, this is a publication that I have for you, but saltwater movement. So we've been monitoring underground saltwater movements. This is USGS study too, down in Homestead area. I don't know if you can read that, but it does say Homestead. So it's right there on the I guess the marginal influence of the Everglades down in that area, and the farmland, of course. But as you can see here in 2011, the wellhead monitoring program that they were doing, they started detecting some salinity issues. And you can see how the intrusion now is moving inland. Florida's surrounded three sides, peninsula is surrounded by salt water. So definitely there's going to be some pressure moving as we remove more and more fresh water from these areas, these superficial aquifers, that allowing this confluence, this entrance of salt water. So 2018, and you can see the scale at which it moved, especially at the 2018 green arrow. You can see where it went from 2011 and jumped. Don't have the distance on me right here, but you can see the movement. And so that's another thing that we have to take in consideration is that these systems are they're very fluid, but then again, they are active and involved underground, with our activity above. Okay, so what exactly are we talking about with, underground systems that are probably, bringing in salinity? How does that all work? And I just wanted to put this diagram in here to show you the migration of salts and how that occurs. And it's not a one-time deal. It could be off and on during like a dry period, during droughts, where we're applying water, but we're not applying enough to get it down below root systems. And sometimes that's when we have issues. So we'll start with number one. We got a thunderstorm. The little circles you see are representing salts. And in the down arrows is the movement of fresh water. So within a thunderstorm, we get that fresh water. We get, the soluble salts that we identified earlier. They're going to move downward with that water down below the soil, into the soil, and then hopefully below the root systems with our seasonal storms. We get into the dry season. So that's number two. We start to get into dry season and evaporation. So imagine these salts are within a water molecule or surrounded with a water complex, and there's that water tension of evaporation, transpiration as well. There's a lot of pull upward, as you can see with the arrow. So not only is the water moving upward, the salts are moving with it, and so the water gets to leave. Once it hits the surface, it's gone, it evaporates. But the salt is a rock, so to speak. It can't move into the atmosphere as easily as the water. So with those conditions, we'll go to number three, where we get higher temperatures. If we can't get irrigation out there, fresh water or blended water irrigation, to move those salts back downward, they're going to hang out at the top of the soil level. And it could be just within an inch, or it could be, again, 4 inches, but it's in that area of root zone, which is the concern. So that's what we're talking about as far as flushing and leaching. If we can't rely on the storms, we'll have to move toward potable or blended water. I won't say potable, but at least fresh water. It could be surface water to move these salts downward. And this is not only for turf. We see this in this is ag influence all the time. But it could be ornamentals or any sensitivity. Again, going back to the right plant, right place, we forego these issues that we see just by the principles of movement of salts. So we have these contact points, and we have them above ground, which could be foliar, could be ocean spray, or it could just be irrigation with reclaimed water or high salt water. Poor quality could be affecting it. And then, of course, root below ground. You saw how the migration salts and the flushing. So those are some properties we need to look at. There's a number of manifestations, I guess you could say, with foliage and the marginal burn. It could be bud, it could be fruit drop. There could be a lot of signs regarding foliar or salinity issues, the accumulation of salts, and this could be the salts that are picked up through transpiration during drier seasons, and it's within the plant. So we can have that as well. As you know, mangroves have the ability. White mangrove, you'll see that little chalky white salty substance, which is salts. It can push those out of its foliage, but other plants maybe not so easy. So we could get leaf burn all the way to necrosis. And overall, it's a reduced aesthetic appeal. It's also an insect or disease opportunity as well. So getting poor health. So this interaction of these salts, and I put this in here just kind of show over time, if we do get accumulations within that 4-inch, 6-inch root zone area, a couple things happen. First, with interaction of soil. So when we get saline type water in there, it goes into the soil. The sodium starts to, and the chlorine ions separate. And when the salts are dissolved in the water within the soil level, the dissolved sodium and chloride ions in high concentrations can displace these other mineral nutrients that you see around these root systems. And so plants then absorb the chloride and sodium instead of these other needed plant nutrients. It also disassociates calcium, primarily calcium and magnesium, from the soil itself, and it starts to lose structure. And that's where the SAR, that soil sodium absorption ratio, is critical into that area. And basically, again, I don't mean to get off in ag, but we'll see that a lot in ag too. But the chloride ions are, it's transported into the leaves where they can interfere with photosynthesis and chlorophyll production. And so that's what we're looking at a lot of times with marginal burn, coming up through the system. And so that's just another principle of transport that I wanted to kind of explain a little bit more. When we talk about, there's one thing for water salinity, and then soil salinity is another set of issues as well. So within the soil, definitely, we can impact the root systems and also stunting. So some of the symptoms could be, yellowing, browning of leaves, leaf drop, and decline in overall plant vigor. These are 2 tomato plants. This is more or less a greenhouse example, but maybe something you've seen before, or if you're a master gardener, you've seen in the plant clinic come through. Here's another list, which is in an EDS document too. I pulled this information out, but the common symptoms of salt entry, and I'm not going to read all these to you, but some of them may be, when we say witch's broom, I think of a pathogen or something else going on, but yeah, it could be salt too, manifesting that type of appearance, so tuft or stunted appearance. So things, sometimes it may hide itself. So we have to be more, holistic in our evaluation as well. All right, so let's get down to the measuring, the soil and water salinity analysis. Again, we typically we're referring to EC, that electrical conductivity, and looking at salinity values when our analysis. So we're going to inspect or use that ET test to measure the ability of that solution to conduct electricity, and it's going to provide a value. ECW is the value that we look at, and it can go through a formulation too as well. But just to let you know, that's our reference as we move into looking at these values. And so within this value, a lot of your tests, when you take, take a sample and send it in, you're going to look for soluble salts. And generally, we're looking at the decisiemens per meter, and how that value is recorded. That's what we're going to look at. So the ECW, as you can see here with the blue arrow, matches up with the unit, that decisiemens per meter. And what we're looking for, that range is to be less than 0.75. Now, there are some conflicting research, but they all generally are within this area, within this desired range as far as salinity and where you would like to have a preferred, area for your plants. But again, going back to our right plant, right place, and our salt tolerance that are built into a lot of our plants that we have on the market today, probably not as big as issue as we think it is. This is out of another document. This is at Tour and Lusk that I'll share with you, but this is the salinity profiles, and what you're looking at on the right is the management plant tolerance. And I don't want to go through all these, but I do want to recognize again, we're looking at the measurement ECW, or that DS/M superscript A. The older way, believe it or not, the TDS is in ppms, and a lot of our extension offices still report back to, you can run a quick um, test on, for saline, especially in water. And sometimes it does come back reported at test. So you can hold them up side by side. And again, this is a document that you can look at. And so that if you get a reported range in either one, you're going to get the remarks on the right. That's going to kind of give you some guidance and what you can understand about your landscape. This is the typical water test form. You can Google this. This is on at our IFAS extension. It's probably an EDIS document as well. If it is, it comes with more guidance on the back. You have all the sampling information and the test. So as you can see on underneath the test column, about midway down, right above pH, electrical conductivity. So that's something that you're going to be able to get a report on. I do want to show you this one too. This is the third party one, and in ag and in a lot of commercial landscaping, we use A&L Southern Ag Laboratories to do a good job and respected too within the industry. But this is what I'm wanting to show you is that they kind of give you guidance. If you can look, what we have is two sample sets here, and we have number one pond and number two waste treatment. It was collected from a wastewater treatment facility. If we start on the first column, pH, we look at the top. It's almost neutral. It's 7.1 for the pond water, and it's neutral for the wastewater. Conductivity, however, is drastically, I wouldn't say drastically, but it's definitely higher in the waste. It's 1.93. Now, this is the millimoles per centimeter, which is exactly the same as 1 DS per meter. So what you're looking at there again is the same value that we would give on that previous slide for that. If we're going over to the right, where you can see the highlights again, you have TDS, the total dissolved solids. But the pond, of course, is slightly lower than the wastewater. One that really stands out, though, is the sodium, the SAR. And again, the SAR is going to be more determinant upon soil health and how much we can keep that calcium, magnesium within that soil structure to maintain structure. Typically, we see that more in clayey soils. So again, within our Florida soils, if we're in the sandy soil, not an issue. But again, it does give you some guidance there too as well. Managing salts as far as mitigation strategies, if we do have issues where we can't, resolve them either through genetics, through better planting or systems or maybe filtration, let's look at some of those ways. So the goal is to leach the salts away from the root zone. And again, knowing your root zone is important too as well. So knowing the species, that plant species and the habitat and culture that it's generally cultivated in, that's important. And that's going to give you some guidance as far as how long you want to run the irrigation system. And, it's somewhat involved. You have to have a good understanding of your percolation. So if you do get a lot of puddling, that's not perking as fast as it would on sandy soils. If you have sandy soils, you're probably going to get a pretty rapid flush. And you shouldn't have to run your system too much longer than you typically would to get that rain, to get enough of the fresher water value of pushing the salts away. So that's one of the strategies that you can put in as far as your planning. So since landscape irrigation of many of Floridians is subject to restrictions of water management districts, and I think Hillsborough County, a couple of you are on here. I think you've been in a water restriction 3 years maybe or longer during the wet season, just because of the availability of water and all the build out that's going on. And also, if you looked at the unseasonable, we call it unseasonable, probably weather variability that we had this year along the coast of Florida, particularly on the west coast of Florida, a lot of us are still in extreme drought conditions. So salinity definitely could be an issue. So knowing that too, and knowing that, definitely check for variances too within your water management utilities or water management district may allow you to flush, particularly if you're on the west side of 75. There's a lot of areas that just did not get the rain. I can tell you that. My yard's brown. But if the salinity problem is a result of irrigation water, then we need to locate a new source. It may be that you have to, disconnect from that wellhead itself, either until it goes, mixes a little bit more with fresh water, or it may be an issue to where you may have to hook on some filtration because that's an issue as well. So if the landscape's prone to salt problems, then maybe your alternative would be to again go back and choose better plants to go back in. Try not to fight it. Again, we have these seasonal, natural leaching. So if you're at the tail end of the drought, maybe there's something that you can do to either augment a little bit hand watering if necessary, just to get us back to the wet season is helpful. If you have, this is where I was when I emerged out from Hurricane Ian, last year. Yeah, gosh. But you can see there's a lot of debris, a lot of things, as far as recovery efforts within flooding, inundation. This is what we've been telling the people on the coastal situations: remove debris and sediment. And the sediment could be deposits that maybe you can wash on into your soil profile, or you are going to have to, rake or remove a little bit more mechanical means. Definitely irrigating and getting movement back of water back from the surface downward to rinse off not only the salts, but a lot of treatment, sewage treatment, a lot of septic tank. You do have a lot of mixes of heavy metals, or, a lot of things are going on within that water, pathogens as well. So we need to move them down in the soil profile. Soil is really good at taking care of a lot of things in filtration. So monitoring at that point. Of course, replacing dead plants is needed. The issues with lawns, you could come back in and aerate, and then quality compost back into that area. You could even use quality compost about an inch and a half around the plant systems of ornamentals if they're affected. That's going to help bind and tie up some of the salinity as well. At least get things operable again as far as soil profile and good movement is what we're looking forward to as well. This is a new product. We do have research on this. I do have a document to explain biochar a little bit more to you, but biochar is reported to reduce plant stress, from salinity and improve plant growth and soil health. There's a lot of things going on with biochar. First thing is quality of biochar. Depending upon what they use to make biochar, and it's basically charcoal, it could affect its characteristics and how it properties that it has once you put it out. So just be mindful of that. So you might want to do a test site with biochar. It does have other values for landscape, but this is one. It's pelletized, so this is going to make it easier to apply to soil. Again, I do have information. This is cut out of the document here. So biochar, just for the definition, it's a black carbon. It's derived product from organic materials, rich in carbon. Carbon is found in soils in very stable, solid forms. Often it's deposits. So it's some of these historical, could be from prehistoric fires and stuff. It's also can be derived from charcoal, from wood itself. So there's, again, different values, different, applications of biochar too, that you can read up on, just something to catch up on. One of the things that often comes out is, oh, you got to put gypsum. Well, you don't put gypsum on sandy soils. It's just not going to work. If you had clay soils, yeah, you can definitely remediate your soil if it's more toward the clayey side. But otherwise, it's not recommended as general treatment for salinity issues in Florida, particularly within your home landscape. So that's not going to help alleviate the salinity issue. remember it's actually a insoluble salt. Plant tolerance, another document that I have for you, especially in coastal areas. These are some palms that you could consider, and their growth habit, and their salt spray tolerance. So if you're on the coast, that might be something to look at. If you're looking at lawn grasses, this is again another document that you can look at as far as seashore paspalum is going to be your toughest one. It's really going to be in areas that are getting continual or seasonal, like the king tides, seasonal issues. Definitely as a selection to go with. So keep that in mind. And then you can come down through St. Augustine's, Bermuda grass, a little bit more tolerant as well. If you're using reclaimed water, here's the recommendations. And also you can see where the sensitivity at the top of the top row across the top is going to give you those DSM values. So that's another reference for you regarding if you want to go in and renovate or put in turf grass or take out for turf grass. Either way, it's going to give you sensitivity regarding each species. This is somewhat recent. It's really good. Explaining again salinity and how to read your irrigation water analysis. This is where I got that sample analysis from the laboratory. And Jennifer, if you want to start posting these links, you can post them all at once if you like, so they'll have time to get them. But
I just did. I just did.
Oh, great! Thank you.
Yeah, they're in the chat now.
Okay, so kind of ending up the talk here, I just wanted to kind of remind you of the references that I'm providing to you, and where I got my information for today. This is another good one here as far as county agents, Jim and others. If you do have a lab, if you need to kind of go back and check and see what's going on in your lab as far as protocol, this is a good one to go by. If you are a county agent, you want to start something within your county, this is, again, these are some stepping stones to get there. So this is soil and container media. And so, as we get into maybe large container plantings, if salinity is an issue, this is something that you could reference for container plantings. The palm reference I made earlier on the table with sensitivity to salt spray palms along coastal areas, this is where that information is located. And the last one here, of course, is the Florida Friendly Landscaping Program, the app itself. Again, overall, it's right plant, right place, following the Florida Friendly Landscape recommendations. Your salt tolerance should not be an issue. If it is, then we got, again, go back to looking at the supply of your water and the quality, and that might, again, go back to filtration. It may go back to shutting down that railhead because it's pulling too much salinity, too much brackish water into, and that's just not going to work. So those are some, things to think about with salinity. Yeah, these are just some review points. Again, EC is the determinant. So you want to look at the electrical conductivity on your analysis. Salt tolerant plants for areas where irrigation water is saline, soils as well, salt buildup. Excessive salts in soils and irrigation water can lead to, as we know, you've seen plant problems. And it could be wilt or nutrient toxicity as well. It could be, again, in the soil, that sodium and chloride, particularly chloride, will hold back some important nutrients. So there's kind of a competition to get into the plant, and the salt's going to win. Not the salt, but the sodium and the chloride. Take home. So yeah, definitely for those in South Florida, just know the conditions you're facing as far as your, the climatic conditions, and making sure you have the right plant palette. If not, put in systems that are going to help remediate that afterwards. So not, being reactive there to correct those issues that I've gone over. And let's say the last one, short and long-term management practices may be needed. So, protecting your soil health, plant productivity, and the environment. Again, just with some of our weather influences that we've had, be mindful of that as far as plant health. Okay, well, I hope this was informative for you, and I'll take any questions or anything you may have. I'll try to attempt to answer
Sure.
them.
I saw a couple of them. Let's see. How far inland does the brackish water from, oh, sorry about that. Just lost my chat. Hold on one second. There it is. I think it said, how far inland does the brackish water from overpumping occur?
That's going to be a hard one to determine. We'd have to follow the USGS water table monitoring system that they have. It's going to be determinant upon your location. The good thing is you can go online to that. You can Google that and get more information regarding your groundwater table levels. It's important to understand,
Okay.
and if there's bringing any inundation.
Okay. Does anybody else have any questions? We only had one listed in the chat. Let me check this Q&A. We don't have any in the Q&A either. So let me just look. I did post your resources. So everybody please copy these from the chat or save the chat. So you can, keep these resources handy. There are a lot of good ones in here. So it doesn't look like anybody has any more questions. Don, thank you so much for joining us this morning to talk more about salinity and the landscape. It was a great webinar and very informative.
Yeah.
So
Left you something with some nighttime literature to read.
Yeah, yeah, absolutely.
I put my email address in there if anyone's got a question or follow up. I'll be happy to discuss with you.
Okay.
All right.
So thank you so much. Have a great rest of the day, everybody.
Bye-bye.